Greetings to Dr. Teh. My name is Amaharit Bimadihi with metric number 77703. Now, I would like to present on the final year project 2 entitled Flood Prediction using a hybrid algorithm, knife-based and logistic regressions. Floods indicate one of a natural disaster whenever the heavy rain downpour tremendously. Based on the Department of Statistics Malaysia 2022, over 6.1 billion of the overall loss, including the houses, public assets, manufacturing building, vehicles, and agriculture, as well as the business franchise or premises, and agriculture sector people who were affected due to the circumstances of the massive flood. Department of Irrigation and Drainage control the alarm system, which also handles the water level as to comprise the flood measurement. Therefore, it will be beneficial to the populations as they could alert any notifications or announcement to avoid the massive flood in real time and in a proper way. Background of study: machine learning, which emerged from the development of a hybrid algorithms to learn from data which has been collected and make predictions based on scientific techniques and methods. The next subsequence describes each of these two machine learning algorithms, which are knife-based and logistic regressions methods, as the algorithms that has been deemed useful for both short and long-term flood prediction, as it can be used in the future. Problem statement. There are two major problem statements for this study. The first one is lack of intelligent warning system, and the second one is inaccuracy from the predicted data. Rodriguez et al. 2022 mentioned that several meteorological departments in affluent nations lack adequate, intelligent, and scalable flood warning systems in their flood monitoring cells. Elmark et al. Mentioned that the inaccuracy from the predicted data have shown that knife-based have the low accuracy in terms of classifications. Research objectives. There are three research objectives which has been identified for this study. The first one is to pre-process the datasets which has been collected from the DID Sarawak. The second one is to improvise a hybrid algorithm from the machine learning, such as knife-based and logistic regressions. The third one is to evaluate the performance of proposed hybrid algorithms, as it will be showing the evaluation metrics and the percentage of the accuracy for predictions. Significance of study. Through this study, it will be beneficial for the populations, especially from Kota Samarahan, Sarawak, as they will be more aware and be more prepared before facing the flood. Therefore, a clear datasets which has been collected and then will be pre-processed and classified by the selected machine learning algorithms, which are knife-based and logistic regressions, as to enhance a hybrid alternative for flood predictions in the future. Scope of study. Diagram shows a dataset which has been collected from DID Sarawak, as is shown the number of rainfall for each day and each month from January until December 2021. This flood prediction, we're using a hybrid algorithm, as it will be assembled or combining two machine learning, which are knife-based and logistic regressions. This study will also use a Python as the main software to develop this hybrid algorithm, as the Jupyter Notebook to run the code, and Anaconda as the navigator. Literature review. There are two main focus for the literature review, which are naive-Bayes algorithms and logistic regressions algorithms. So for the first one is naive-Bayes algorithms. A study in the year of 2020 entitled Early Flood Detections and Alarming System Using Machine Learning Techniques, where the authors were Pooja Mane et al. As the method used was mathematical formulations of flood physical processes. They applied the naive-Bayes algorithms in these mathematical formulations, as it covers certain aspects such as status of the current rainfall, measurement of water levels, visuals of flood in certain area, and other sensor of data. The advantage of this method is it can develop a flood predictions and early warning system that make use of machine learning to forecast flood events, as it works exactly as it has been specified. Logistic regressions. A study in the year of 2021 entitled Scenario-Based Real-Time Flood Predictions with Logistic Regressions, where the author were Jae-Yong Lee and Byung-Hyun Kim. The method that has been used for this study is the database created using scenario rainfall and hydraulic and hydrological models to develop a spatial regression equations, as it fulfilled the logistic regressions specifications that takes regional factors into account. The advantage from this method, as the flood forecast can be enhanced and visualized, which covers certain area, as well as predicting the possibility of flood, whether it can be massive or otherwise. There is a limitation for this study, where other areas cannot be applied by using these regression equations. To build a new database and to create a new regression equations, it can be developed as long as it will be selected for certain area only and cannot be used for other area. Research methodology. The research methodology which has been chosen was experimental, as to analyze the datasets which has been collected from the ID to predict the flood by using two machine learning, which are naive-Bayes algorithms and logistic regressions, as to enhance towards the implementations of hybrid flood prediction for the proper preparations. So for the first one is the collection of the datasets. This datasets was collected from the Department of Irrigations and Drainage Sarawak. The requirements for us to request the dataset is to fill in the hydrological request form as per attached and the formal letter from UNIMAS. After a few weeks, the datasets was collected through email, and the ID Sarawak also sent the hard copy by post laju. Secondly, data pre-processing. Data pre-processing is the most important process before we run our algorithms. So for the first one, we import the specific libraries. For example, import NumPy as NP, import Pandas as NPD, and for naive-Bayes, from sklearn.naive_Bayes, import Gaussian NB, and from sklearn.linear_model, import logistic regressions. After that, we load the datasets using pd.read_CSV, and then we separate the features X and the target variable Y from the datasets. After that, we split the data into training and testing, train_test_split. After the process of splitting the data, we undergoes the handling missing values, categorical variables, and numerical variables based on specific code. And then after that, we create and train naive-based classifier and logistic regressions. For example, for train the naive-based, we use the Gaussian NB, and for logistic regressions, we use the logistic regressions to train the specific algorithms. And then we encode and transform .fit for the model, and after that we predict the model, and lastly for the evaluations based on different accuracy. The third one is hybrid algorithms. After we done the data pre-processing for each algorithms, we assemble both of the algorithms and develop into the hybrid algorithms. For example, we import NumPy as NP, import Pandas as PD, import OS, and then after that we import the libraries from both algorithms, similar like the data pre-processing. And we add on certain libraries such as make_classifications, trend_test_speed, and also the accuracy_score. The fourth one is evaluation metrics. For the evaluation metrics, we have to make predictions on tests and compute ROC curve and AUC for naive-based and logistic regressions. And after that, we plot the ROC curves based on specific code. And then it will show the exact output based on the requested. And after that, we calculate other evaluation metrics which covers certain aspects such as accuracy, precision, recall, and F1 score. And then lastly, it will generate a classification reports as it covers the same thing, similar like other evaluation metrics, as it will show the accuracy for both algorithm which has been assembled. There are several findings which has been computed based on the selected algorithms. So for the first one is naive-based. The accuracy which shown by the naive-based was 76%, and the coefficient matrix is 8508. As for the classification report, the accuracy shown was 76%. Next is logistic regressions. For the logistic regressions, the accuracy also shown the same accuracy as naive-based, which is 76%. After considering each of the accuracy for each algorithms, the both algorithms, naive-based and logistic regressions, has been assembled, and the accuracy showing the increment from 76% to 84%. As for the ROC shown, the naive-based for the AUC is 0.89, which is 89%. As for logistic regressions, 91%. This is the confusion matrix as after the combine to indicate the model predictions. And then after the combination or the assemble from naive-based and logistic regressions, the accuracy was 82.5%, the precision is 91%, recall 75%, F1 score 82%, and AUC ROC 83%. And finally, the classification report is shown that the accuracy for both naive-based and logistic regressions after the assemble, it shows the increment from 76% to 83%. In conclusions, hybrid algorithm displayed a better accuracy as compared with single algorithms only. This study can be enhanced and developed in the future as to give benefits in the society. Thus, flood can be predicted, which could gain a higher estimations of heavy rainfall. This is the references for this study. Thank you.